Okay, we have additional examples here for y is equal to 8x squared minus 6 raised to the negative 40 power. Our outside function will be something raised to the negative 40th power, and our inside function will be 8x squared minus 6. So dy dx will be equal to the derivative of the outside, so negative 40 times 8x squared minus 6 raised to the negative 40 minus 1 will be negative 41 times the derivative of the inside. Derivative of 8x squared minus 6 will be 16x. Okay, let's go ahead and simplify this. Negative 40 times 16 will be negative 640 times 8x squared minus 6 to the negative 41 power. Now, we're going to be using our product and chain rules together here. So we're going to have two different outside functions with two different inside functions. So for our first factor, outside is going to be something raised to the 7th, and the inside is going to be x plus 5. And for our second factor, because we're doing product rule, outside will be something raised to the 10th, and the inside will be 4x minus 1. Alright, so now let's use our product and chain rules together. dy dx, product rule says first times derivative of the second, so first is x plus 5 to the 7th, times derivative of the second, so outside, derivative of the outside would be 10, 4x minus 1 to the 9th, derivative of the inside will be 4. Product rule says plus second, so 4x minus 1 to the 10th, times the derivative of the first, so derivative of the outside will be 7x plus 5 to the 6th, times derivative of the inside, which is 1. Okay, in all the previous examples that we've done, we have multiplied everything out and combined like terms. Clearly, that is not reasonable to do here. So when you're in a situation like this, the best thing to do is to get this in simplest factored form. Which means I need to pull the GCF from these factors, and some of the factors in my GCF will be binomials raised to a power. So what we're going to do first of all is look at the numbers. Actually, let's look at the numbers. Right here, 4 times 10, that would be 4. So I have no
numerical factor that I'm going to pull, which means now I'm going to look at my binomials. I've got x plus 5 raised to the 7th and x plus 5 raised to the 6th. That means the most I can pull is 6x plus 5s. So part of my GCF will be x plus 5 raised to the 6th power. Now I also have 4x minus 1 raised to a power in each. 9 here, 10 there. The most I can pull will be 9. So 4x minus 1 to the 9th power will be part of my GCF. That's going to be the GCF in total. So let's go ahead and set up the set of parentheses. When I factor these two out of those terms, I have, first of all, 4 times 10 is going to be 40. Now let's look at the binomials. I've got x plus 5 to the 7th, and I have x plus 5 to the 6th, which means I need one more x plus 5 when I distribute this. I don't need any more 4x minus 1s. I've got 9 here, I've got 9 there. Plus, I've got 7 times 1, which is just 7, and now x plus 5s. I have 6 here, I need 6, I do not need any additional. I've got 9 4x minus 1s here, 10 there, which means I need one more. So 4x minus 1, close the parentheses. Last thing we're going to do is go ahead and simplify inside this set of parentheses. So x plus 5 to the 6th times 4x minus 1 to the 9th times 40x plus 200 plus 28x minus 7 is equal to x plus 5 raised to the 6th times 4x minus 1 raised to the 9th times
40x and 28x, 68x, plus 200 minus 7 is plus 193. Close the parentheses. Okay, we are now in simplest factored form. All right, find the derivative of this product. Now, excuse me, this quotient. Now, this quotient has 4 minus 9x to the fifth, which means we're going to have to use chain rule down here. We can't use monomial division because the monomial is on the top, not in the denominator. So when we use the chain rule part of it, the outside function is going to be something raised to the fifth power, and the inside function is going to be 4 minus 9x. So let's go ahead and do our derivative. We're going to be using quotient and chain. So dy dx is going to be equal to the bottom, 4 minus 9x to the fifth power, times the derivative of the top, which will be times 21x squared, minus the top, which is 7x cubed, times the derivative of the bottom. So derivative of the outside will be 5 times 4 minus 9x to the fourth, times the derivative of the inside, which is now going to be negative 9. All over denominator squared. So 4 minus 9x to the fifth quantity squared. Okay, let's go ahead and clean this up a little bit, and then we're going to have to do some factoring like we did with our product, because multiplying these two out isn't going to work, and actually if I can pull some of them out, I'll be able to cancel them with some of these. So let's go ahead and rewrite this as 21x squared times 4 minus 9x to the fifth minus, or plus actually, because I have a negative and a negative make a positive, 7 times 5 times 9 is going to be how much? 35 times 9? 350 for 315? 315x cubed times 4 minus 9x to the fourth power. Okay, all over. 5 times 2 will be 10. 4 minus 9x to the 10th. Okay, so now as far as common factors are concerned, 21 actually goes into 315. So that's going to be part of my common factor. I've got 21. I've got an x squared and x cubed, so I'll pull an x squared. 4x to the 9th to the 5th and to the 4th, so I'll pull 4 of those. Okay, and in our parentheses now, as we pull this GCF, means we've got a 1 for our first term. Oh no, we need one more. We've got, for pulling, we can only pull 4, not 5. Sorry about that. So we'll put a 4 here. So I do need a 4 minus 9x here. And 21 times 21 goes in there once with 10 left over. 21 goes in there 5 times, so 15. I need 1x, and I've got all the 4 minus 9x's that I need. Close the parentheses. All over 4 minus 9x to the 10th power. Now we're going to be combining like terms inside this set of parentheses and reducing over here. If I've got 4 minus 9x to the 4th here into the 10th there, I will cancel all 4 of these with 4 of those, leaving me with 6. So now I'm going to have 21x squared. Inside the parentheses, I've got negative 9x and 15x. That's positive 6x plus 4 all over 4 minus 9x to the 6th power. And now, if we're going to have this in simplest factored form, after we simplified what was in our parentheses, there's a common factor of 2 here. We're going to pull that common factor of 2 out and multiply it with the 21. So the 2 times the 21 will give us the 42 x squared. And when I factor the 2 out, it will leave me with 3x plus 2 on the inside, all over 4 minus 9x to the 6th power. Okay, that was labor intensive. Here we have another one. We're going to use product and chain rule. It's going to be first factor. That's going to be my second factor. Again, outside is something to the 6th. Inside is going to be 5x plus 4. So this is going to be product and chain. So f prime of x will equal first, which is negative 3x, times derivative of the second. So 6 times 5x plus 4 to the 5th power, plus the second, 5x plus 4 to the 6th, times the derivative of the first, which will be negative 3. Oh, we forgot to times the inside function over here. Let's get rid of this for a second. Make sure you always double check your work. So derivative of chain rule, 6 times 5x to the 4th raised to the 5th, times derivative of the inside, which is going to be times 5. Now plus the second, which is 5x plus 4 to the 6th, times derivative of the inside, derivative of negative 3x is negative 3. That's better. Which is equal to, again, let's go ahead and factor. I have a negative 3 and a negative 3, so I'll pull a negative 3 out. I have 5x plus 4 to the 5th and 5x plus 4 to the 6th, so I can pull 5. So 5x plus 4 raised to the 5th power. Now that's it, so let's go ahead and divide both of these by the LCD and put what's left inside the second set of parentheses. So that's going to be 6 times a 5 will be 30, and an x. I have 5, I pulled 5, so I'm good there, plus I have 6, I need 6, I have 5, so I need one more 5x plus 4, and I have the negative 3. Simplifying further, it's going to be negative 3 times 5x plus 4 to the 5th, and 30 plus 5 will be 35x plus 4. Close them up. Okay, that's going to be simplest factored form. Okay, now in this particular case, you could go two ways. You could do this using the chain rule, making a fraction be the inside function and the outside function being something raised to the negative 4 power, or we could use the rule of exponents and split this, and we could actually flip this over. So in other words, sometimes doing some algebra before you do your calculus might make things a little bit easier. 2x plus 3 to the negative 4 power over 5x minus 1 to the negative 4 power, using rules of exponents. And also, if we have negative exponents, that means reciprocals, so they're actually going to switch positions. 5x minus 1 to the 4th power over 2x plus 3 to the 4th power, and then we can differentiate, and we'll use a quotient rule and chain rule together. So f prime of x is going to be equal to the bottom, 2x plus 3 to the 4th, times the derivative of the top. That requires chain rule. So 4 times 5x minus 1 cubed, that's the outside, times the inside, which is 5, minus the top, 5x minus 1 to the 4th, times derivative of the bottom, chain rules. It's going to be 4 times 2x plus 3 cubed, derivative of the outside, times derivative of the inside, which will be 2. All over the denominator, or the bottom, plus 3 to the 4th squared. Again, this is another situation where it's not reasonable for us to multiply this out. What's more reasonable is for us to pull factors. Now you could clean this up a little bit and go ahead and multiply the 4 times the 5 and the 4 times the 2. In fact, let's do that because it will look a little cleaner. I know we didn't do that in some of the others, but this will be 20 times 2x plus 3 to the 4th times 5x minus 1 cubed minus 4 times 2 is 8 times 2x plus 3 cubed times 5x minus 1 to the 4th. So I change positions using commutative property so that all factors are in the same position that are common to each other. And then power to a power, this is going to be 2x plus 3 to the 8th. Now let's factor. Numerically, greatest common factor is going to be a 4. And for the factor of 2x plus 3, I can pull 3 of those. I've got 3 here and 4 there. I'll pull 3 of the 5x minus 1. Okay, and then let's go ahead and figure out what to put in the second set of parentheses here, or the third set in this case. 4 times 5 will give me 20, and I need 2x plus 3. And I'm all set with the 5x minus 1. Moving on to the second one, I need times negative 2 to give me the negative 8. I have all my 2x plus 3's. I need one more 5x minus 1. All over 2x plus 3 to the 8th power. Now, I'm going to simplify, and I'm going to do some reducing. So 3 of these can cancel with 3 of these, leaving me with 5. So it's going to be equal to 4 times 5x minus 1 cubed times, when we distribute, I've got 10x plus 15 minus 10x plus 2. 10x minus 10x will be 0. 15 plus 2 is going to give me 17. All over 2x plus 3 to the 5th power. And then 4 times 17 is going to give me 68. 5x minus 1 cubed over 2x plus 3 to the 5th power. Okay, problems like these can be found on page 163, numbers 1 through 44. For example, in a word problem, total cost. A total cost function is given by c of x is equal to 2,000 times the quantity x squared plus 2 to the 1/3 power plus 700, where c of x is the total cost in thousands of dollars of producing x airplanes. Find the rate at which the total cost is changing when 20 airplanes have been produced. Okay, so when they talk about the rate of change, that means we need a derivative. So we're going to do c prime of x is equal to, when we do the derivative of the first term, it's going to be 2,000 times 1/3, so 2,000 thirds, times x squared plus 2 to the 1/3 minus 1 will be negative 2/3, times the derivative of the inside, which will be 2x, plus the derivative of 700, which is 0. Okay, let's clean this up a little bit. So this is going to be equal to, because we're going to be plugging numbers in, so let's go ahead and write this as 4,000 x over 3 times x squared plus 2 to the 2/3 power. We need to evaluate this for how many airplanes? 20 airplanes. So it's going to be 4,000 times 20 over 3 times 20 squared plus 2 to the 2/3 power. And when you put this into your calculator, it should come up with $489,574 per plane. So the rate of change, the total cost, is increasing by nearly $500,000 per plane at 20 planes. Okay, problems like this can be found on page 164, numbers 71 through 73.